Hi, I am Sanjay Patel. In this lecture, first of all, we are going to solve one or two problems based on the definition and the equations, the Cartesian equation of a sphere, and then we'll discuss intersection of sphere and the other objects like plane and line, etc. Okay, so let us begin with some examples, one or two examples. Let me take first simple example. Determine whether the equation x square plus y square plus z square plus 2x plus 4y plus 6z minus 11 equal to 0 represents a sphere or not. And if yes, then find its center and radius. Find its center and radius. So let us solve this. First of all, comparing the given equation with the general equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, we get see 2x, x coefficient is 2 here, and here x coefficient is 2u. So 2u is equal to 2, we'll get u is equal to 1. Remember, just whatever is the coefficient given of x, y, z, you have to divide it by 2 to get the values of u, v and w respectively. Like 2v is equal to 4, so v is equal to 2. And 2w is equal to 6, so w is equal to 3. Also, the value of d, this constant is d. d is equal to minus 11. So we get these 4 numbers. Now to check whether it is a sphere or not, we will check that condition. Now you know the condition is that u square plus v square minus u square plus v square plus w square minus d. Let us find the value of this expression. If this expression turns out to be positive, then our given equation is definitely a sphere. So u, v, w are 1, 2 and 3. So 1 square plus 2 square plus 3 square, and minus d means minus 11. So 1 plus 4, 5, 5 plus 9, 14, 14 plus this minus plus 11. So this is 25 and it is positive. So therefore, the given equation is a sphere. Okay. In this case, the center of the sphere is C is equal to minus u, minus v and minus w. What are u, v, w? They are 1, 2 and 3. So the coordinates of the center will be minus 1, minus 2 and minus 3. So from the given equation also you can directly find the center. That will be very useful in future. Say suppose this type of equation is given and you are told that it is a sphere, and find the center and the radius. Just divide the coefficient of x, y, z by 2 and change its sign. If it is plus, make it minus. If it is minus, make it plus. So here it is minus 1, minus 2 and minus 3. That will be the center. And finding the radius, just take the positive square root of this condition. So the radius will be, I can write like this, and radius A is square root of u square plus v square plus w square minus d. So it is nothing but square root of 25 and it is equal to 5. So radius of the sphere is 5. So the problem is solved. Let us take another example based on the basic theorem or the basic general form of sphere. So second example, example 2, find the Cartesian equation, find the Cartesian equation of a sphere which is passing through A into bracket A0, 0, the point B0, B0, then the point C, 0, 0, C, small c, and the origin, 0, 0, 0. Remember, to derive the equation of a sphere, you should have center and radius. The center and radius are not given in this example. And also remember that whatever the equation we are going to derive in this problem, that is very useful. So you can remember this final equation of the sphere for the future purpose. Okay. Now, to derive the equation in this example, we assume that suppose the required sphere is given by x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Okay. And let us call this sphere as S. S then colon means this is the label for this equation or the name of this sphere S. Okay. Now we know that this 0, 0, 0 as the point 0, 0, 0 lies on the sphere. So I can write like this. This is our understanding. O00 belongs to S, O000 belongs to S, implies this point must satisfy this equation of the sphere. We must have, you can put x equal to 0, y equal to 0, so you will get 0 square, that is 0, 0, 0 because x, y, z are 0. These three terms will also be 0 because it is containing x, y, z plus d equal to 0. So as a result, we are getting d equal to 0. Remember, we have assumed that the required equation of the sphere is this, and we don't know what are these constants c, v, w and d. So our job is to find these numbers, and we have got the first number d in this using the condition that this sphere is passing through the origin. Now this sphere is also passing through the three numbers a, b and c. So I will be using another condition. Also, the point A0, 0 belongs to the sphere S. Okay, so this implies I can put x equal to a, y equal to 0 and z equal to 0. So we'll get a square plus 0 plus 0 from this equation. X equal to a, y is equal to 0, z equal to 0. And here plus 2ua, okay, plus 0 and d, we have already obtained the value of d, so I can substitute that, plus 0 is equal to 0. So what I will get from this is a square plus 2ua equal to 0. So that gives me the value of u. So I will get u is equal to minus a by 2. Taking this a square on this side and cancelling 1a. So we'll get 2ua is equal to, rather 2u is equal to minus a. So u is equal to minus a by 2. This is my value of the constant u. The same way, I can find the values of v and w by putting b and c, this remaining 2 points, in the equation of the sphere. So I am not going to write every step, just you can verify. So I am writing similarly as b and c also belongs to the sphere S. We can get the value of v is equal to minus b by 2, and value of w is equal to, and w is equal to minus c by 2. So you have obtained all the required constants in that equation or sphere which you wanted to find. So in this equation, now we are substituting the values of u, v, w and also d. D is equal to 0, u is equal to minus a by 2, so this 2 gets cancelled. So let me call this equation as star. So putting the values of u, v, w in star, so substitute the values of u, v, w and d in star, we get x square plus y square plus z square, then minus 2ux, u is equal to minus a by 2, so we'll get minus ax, similarly minus by minus cz, and d is equal to 0, so we'll get only is equal to 0. So this is very important equation of a sphere passing through 4 points, a 0 0, b 0 b 0, c 0 0 c, and the origin 0 0 0. Okay. Now we'll be discussing intersection of sphere and a plane. Okay. So before we discuss the intersection of sphere and a plane, let us recall the formula to find the distance, perpendicular distance of a point outside of a plane. So let me say intersection of a sphere and a plane. Intersection of a sphere and a plane. Okay. So first of all, note that if we have, say, a plane, let me consider a plane. Okay. And a point here is given outside of this plane, say P, and if we draw a perpendicular from this point onto this line, just a minute. Okay, let me, yes, so draw a perpendicular from this point onto this plane. and suppose the foot of the perpendicular is capital M, and we want to know what is the formula to find the distance. This you already studied in your higher secondary. So if the equation of this plane is, say, ax plus by plus cz is equal to d, and the coordinates of the point P, which is outside of this plane, is x1, y1, z1, then the perpendicular distance PM is given by mod of a into x1. Just substitute x1, y1, z1 in this equation and write like this: a into x1 plus b into y1 plus c into z1, and take this d on this side. So minus d upon square root of a square plus b square plus c square. So this formula is also very important for finding the distance, perpendicular distance of a point from a plane. Okay. So using this, we'll be discussing the intersection of sphere and plane. What do you think? If have a sphere and a plane, what are the possibilities? So first of all, let me consider a sphere in R3 as this equation: x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d equal to 0. Remember that throughout the chapter, the general equation of a sphere in the Cartesian form we are going to consider like this, and we label as S. If you have more spheres, we'll label as S1, S2, and so on. So I'm taking a sphere and I'm taking a plane, and plane in R3, and this plane will be denoting by always a symbol pi. Pi stands for the label for plane, and this equation of the plane I am taking as ax plus by plus cz, and is equal to, I will be writing now k because d is already used here. So we have these two equations. This equation number 1 is the equation of sphere, and equation number 2 is the equation of plane. Remember, both are set of points. So we want to discuss the intersection of these two sets. Okay. Remember the center of this sphere. Just note that the center of the sphere, the center is given by C, whose coordinates are minus u, minus v, and minus w. And the radius, if I denote it by r, then the radius of the sphere, which is given by equation number 1, you know the formula now. It is u square plus v square plus w square minus d. Okay. Now, to understand the intersection of sphere and a plane, will be dropping a perpendicular from the center onto the plane. So let me explain by the figure. Okay, I'm taking a sphere. Say suppose a sphere is given, and a plane is also given. So I consider a plane. Okay, And let me extend this. This is a plane. Now we draw perpendicular from this center of the sphere, which is C, onto this plane. Our sphere is S and the plane is pi. So let me show that this is actually a three-dimensional object by drawing a circle like this. Now we draw perpendicular from the center onto the sphere. So like this. Okay, this is a perpendicular of let me remove this. So yes. Let me change this point. And suppose this is the center. And the foot of the perpendicular is M. Okay, this is the perpendicular. You know that this thing is the radius of the sphere. This is the radius of the sphere. Cm is the perpendicular distance. So this is also, this much is also the radius, and this distance cm is bigger than the radius. So obviously in this case, if this situation arises, you can say immediately that the plane is not intersecting the sphere. We can have different situation. This is the one case. You can note down that in this case, the cm, distance cm is greater than r. So the intersection of plane and the sphere is empty set. So S intersection pi is phi. So this is case 1. Let me call this as case 1. Same way, we can have case 2. So I am taking again a sphere. Let me just copy this. This is, I am also copying this and keeping over here. Now in this case, let me not do this way. This is my sphere with center C and radius R. Okay. And I have a plane like this, say like this. This is a plane. So okay. Shit. Let me do this. Yes. Okay. So this is my plane, and we draw perpendicular from the center And so that we'll get this perpendicular distance cm, which is same as the radius of the sphere. So in this case, we have cm is equal to r. So the plane is just touching the sphere. So intersection is only this one point, which is m, or you can say p, whatever. So in this case, I can write S intersection pi is equal to say m, not p. It is equal to m. So I can say the plane is tangent or is tangent to the sphere in this case. So what you have to do is to discuss the intersection of sphere and a plane. First of all, find out the center and find the perpendicular distance of the center from the plane by that perpendicular distance formula which we had discussed earlier, and then check whether the perpendicular distance cm is greater than r or is equal to r or less than r. What will happen if the distance is less than r? So that will be our third case and an important case. So the third case is that we have a sphere like this with the center C, and let me draw this way. This is a sphere S, and we take a plane like this, say okay, and this plane, it is cutting the sphere in many points. So there are three situations, as you can immediately understand, which is described here. So this is the intersection. The plane is intersecting the sphere in infinitely many points in this case. So this is the center, and we draw perpendicular from the center onto this plane. This is the foot of the perpendicular, which I am calling m. Okay. So what I am getting here is again the intersection as a circle. So circle is our intersection set of the plane pi and the sphere S. So I can say S intersection pi is nothing but this circle as shown in the figure. This M is actually the center of the circle. So just note down that M is the center of the circle of intersection. Okay. And what is the radius of this circle of intersection? That you can immediately see that this distance is the radius of the circle of intersection. Suppose this point is P, and if you complete the triangle, CMP, then you know that it is a right angle triangle. So triangle CMP is right angle triangle. Okay. So we have in this right angle triangle, CP square is equal to CM square plus MP square. Okay. So if you want to find the radius of this circle, which is given by MP, if you want to find this MP, then just put the value of CP. What is CP? This CP is nothing but radius R of the sphere. So Cp is equal to radius of the sphere, and this Cm, which you already obtained as the perpendicular distance. What is C? C is the center, minus u, minus v, minus w. What is the plane pi? It is given by ax plus by plus cz is equal to k. So putting the values of center and this coefficients in that formula, you can get the distance cm. So getting Cp and Cm, you can find out the value of Mp using the Pythagoras theorem. So this way we can find the radius of circle of intersection. It will be interesting to know how to find the coordinates of the center of this circle. As you can see, circle is a plane figure. It lies in that particular plane. Ax plus by plus cz is equal to k. But we can represent equation of circle in 3 dimension also. So we'll be discussing that in the next topic, and we'll be discussing some examples of intersection of sphere and circle, and we'll be finding the center of this circle of intersection and also the radius. Okay. Thank you.